In this video, we are going to graph a log. So just in general, what does a log function look like? And the only one we're going to graph is this, but we are going to compare it to what is that like in a real life kind of a situation. So if you were to graph y equals log of x, okay, all logs have a very distinct look to them. So if this is the one that we're doing, we go into our y equals and we graph log. Right, so all I'm going to do is I'm going to be pressing this log button and log x. And if I press graph, that's what the graph looks like. So what happens is you have this line that kind of starts infinitely low and then it graphs and it kind of levels off. So a log graph goes up very, very fast right away, but then it levels off. And it never like truly levels off. It always increases, but it increases at a painfully slow rate. And that's what all logs do. So that one's just a basic log. If you were to do the natural log, so if we clear that out and do a natural log of x, all you're going to see is just kind of a different angle to it. But in general, all logs kind of have this look to it. So if we were to graph this one, we're going to have the natural log of 4x. Put that in parentheses, and here's our graph. So same thing. And then we're going to talk a little bit of detail on this. So if we're going to graph that one, it does have a tendency to pass through a 1, 0, unless you're kind of shifting it left or right or up and down. And your graph is very, very steep, and then it kind of starts to level off. Okay, so that's a very rough sketch to it. What all logs have, too, are an asymptote, and they have a vertical asymptote that hugs the y-axis. So that asymptote is basically a wall. It's something that the graph approaches but never hits. So since it's a vertical line, none of the graph is on the left side, all the graph is on the right side, which means you have a domain issue. Which means that you can only log certain things. So you can't log a negative value. It's not going to work. You also can't log 0. 0 is where the asymptote is. So that x value is 0. You also have a problem. You can only log positive numbers. So with that, you have a domain issue. So your domain are your x's as long as they are greater than 0. Okay, you can't log negatives, you can't log 0. The range, so your domain are your x's, and then the range are your y's, those are your outputs. I looked at that kind of visual, that this graph goes down forever, goes up forever. It does have an asymptote here. It's hard to draw on a solid, thick, dark line. But this graph does go down forever, so it covers all the y values down below, and it does go up forever, but just at a very, very slow rate. So this is all real numbers. It covers everything. It covers fractions, decimals, positives, negatives, fractions, I already said that, square roots, cube roots, pi, anything. Okay, so where does this exist? What kind of a situation actually has that? And it's something that pretty much affects everybody. It is that if you are charging a battery on a phone, for example, it always seems like you get a pretty quick half charge, like if it's charging from pretty much nothing. It seems to get to that 50% pretty quick, but then it kind of levels off, and then it seems to take a lot longer to get the rest of it. And that's just the way batteries charge, is they charge with a logarithmic kind of a graph look to them. So that's totally normal. That's how they're supposed to charge. Another kind of example to that is a Tesla battery, Tesla charging. So these are, and I pulled this information from a forum on Tesla, and they all kind of had this nice logarithmic kind of look to them. And all this are just different models, different batteries. Bigger batteries or can have a bigger range. So what I did was I took this red one. I took this Model S 85, and it had a range of 265 up here. So I kind of went across it. That was 265. I considered that fully charged. And 40 minutes into it would give you a range of 178. So 40 minutes in, give you 178 miles. Out of the 265, charged at about 67%. So in 40 minutes, you got 67%, but then in another 40 minutes, that didn't finish it off. It came close, but not quite. In fact, an hour into it, you would have had 227 miles, which is probably plenty to get to wherever you're going or the next one. So 60 minutes. So it just has that same kind of logarithmic that in an hour you can get almost all of it charged, and all of the batteries had that exact same feel, which was very similar to just a regular battery in general. All right, so that was just a rough idea of graphing logs.